Okay. So thank you, everybody. My name is Peter, or Piotr Tuszyn, and I'll be talking to you today about lessons that we learned ever since we transitioned into doing IoT projects almost exclusively. Word of two warnings. One, it's been said before, my voice is having a little bit of a hard time. So, any sort of glitches, you'll have to, cut me some slack. Yeah, I'll be doing my best, but you probably hear. And the other thing is I'll be doing this keynote in English. There are many reasons for that, but first and foremost, when talking about technology, we tend to use a lot of English words anyway, and mixing them in, with Polish and with my voice, I don't think these things mix well together. So let's get started. I like to start with, just a quick rundown of who am I and why should you care about whatever I have to say. Like we've said in the intro, I've been building apps, I think probably before the term app was even coined. And therefore that was the days and times of Palm OS, which is my personal favorite, other than iOS and Android, obviously, but my personal favorite mobile OS. It's been powering devices like Palm Tops, something that you don't see very often nowadays, or Symbian or Windows Mobile. So that's where I kicked off my career. I'm currently working with Intent. Intent is it's a consultancy. There are many words for it, but like consultancy or sort of like a boutique app shop that helps companies build net new. So like things that haven't really been done before in the space of IoT, or as we like to say, PXD. And I'll talk about this in more depth in a sec. I'm an ex-founder. I've had my own startup. I know how it is to be a founder. I know how it is to to wear many hats. I have some experience as a VC, so I know sort of both sides of the table. I once in a while I mentor startups in various programs such as Google Launchpad or ReactorX, and I'm personally a huge fan of hackathons, emerging tech, augmented reality, which I think is going to be huge either this or next year, voice UIs, fencing, and aviation. All right, Intent. So my current employer, like I said, we are sort of like a app consultancy, or like an app shop that does things exclusively at the intersection of physical and digital. This is the sort of niche that we selected a while back. So as you see here, we're old guys. We've been in the business for over 14 years now, which is crazy. And we started off as Info Mobile, and there's many reasons for which we decided to change the name. But along with that name change, we decided to sort of narrow down our focus and really try to position ourselves into like a very, very tiny, but really interesting for us niche that that is PXD. So stuff that is done at the intersection of physical and digital. We employ almost 100 people, which is again pretty crazy. Vast majority of our business comes from the US, and again after being this sort of like a 360 app shop, so we used to do we still do, but we used to do a lot of really different projects without any real focus. So we would do industrial grade, machine learning on the edge, but also we used to do a landing page for someone, and we decided that we really want to focus in in one single space. Also because when you look at businesses like ours, when you look at their websites and you take away the logo, they all look the same and they all offer the same thing. So we decided that we want to differentiate from the pack. What differentiates a typical mobile project from a, as we like to say, PXD project? In in typical projects, you have like the two dependencies. You have the back end and the front end, right? So you have the mobile app, which is usually called the front end, and that mobile app, it talks, but it doesn't really have to talk in some cases to a backend that is built by the backend team. And this is all the dependencies that you typically have, other than like third-party services like analytics, but these are vastly outside of your control. In PXD projects, there are just much more moving pieces that impact everybody's work. So, whatever happens on the firmware side, because you will have to be talking to a firmware because you have a device, and that device also has some software running on it, which is typically called firmware, and there are developers behind it. And so you don't, versus a typical mobile project where you have your backend guys, you have like perhaps like a REST API or a GraphQL API. These tend to be pretty well documented, right? So you might have like a Swagger spec of an API. So in firmware, you don't get that stuff. You typically get a massive PDF or Word document. Oftentimes it's in Chinese or Mandarin because it's coming from a vendor directly to you. So again, adding a peripheral to a project like a device, it adds an entire new dimension of complexity for you. And the firmware is just one thing. So other than firmware, there are things like, regulatory approvals, right? So contrary to what a lot of people believe, it's not enough to implement Bluetooth stack and slap Bluetooth logo onto your device. There's just so much more that comes to it, like licensing, right? Or, chip selection, because there are many vendors, mechanical engineering, supply chain. All of these things add a lot of complexity to a project. And I will, over the next few slides, try to, tell you some of the gotchas that we encountered during our career or history of doing a lot of IoT projects or PXD projects for that matter. So first thing that you need to get through your head is, and it's a cliche sort of thing, but hardware is hard, right? And before doing any sort of hardware project, because it's such a big commitment to a founder and to a VC that typically finances the guy, is they're looking for validation, and they will do Kickstarter campaigns or Indiegogo campaigns without really having a real device, which is funny because they will get really close to reality, right? So they will produce videos that show a device. You see the device. You will have like renderings or images or lengthy descriptions of how a given piece of hardware works, but many times is vaporware. And unfortunately, fortunately, unfortunately, they have to validate, so they have to verify whether or not the market is ready for their product, or if the market is receptive enough for this product to turn, to be turned into a business. And so there's nothing wrong with that approach. Just the contrary. I think, like before deploying, hundreds of thousands of dollars or millions of dollars into building something, you need to validate it, right? The problem is oftentimes the founders are not technical, and these ideas, they're coming from them directly. And guess who's going to be responsible for implementing them down the line? You or us. And so oftentimes, I've stumbled upon situations where we've had a very promising client approach us. Like our folks did a quick Google search for whatever the project name was, and they would see like they would get literal heart attacks when they've seen like on the Kickstarter page, we're doing this, and that, and we're shipping in 3 months, right? And so this is really anything that you can control, but like beware of vaporware, and be aware that there is a fair amount of vaporware going on, especially in hardware. And one more thing, reality distortion field, like the thing that Steve Jobs had, like he would like understand reality differently. So reality distortion field combined with vaporware, I think it can lead to very dangerous places. So again, like, totally something that you really don't have a lot of control over, but just something that, you know, worth to keep it in the back of your head to, you know, to not get that initial heart attack. Aside of hardware is hard, you know, hardware takes a long time. Anything that has to do with hardware or peripheral, so something that is not running exclusively on your phone, but, you know, there's some empty space and there's another device and they're talking through, you know, radio waves, it poses a lot of overhead in time, and a lot of other things that we're going to be talking about in a sec. But like a typical, you know, engineers will know that debug, run, repeat loop takes much longer because of the peripheral. Sometimes you will have to do some manual work to bring the peripheral back to its original state, so you can try and test something that you just tested 30 seconds ago. Debugging peripherals is much more complex thing than you know, debugging a mobile app. But we're going to talk about telemetry in a bit. However, again, there's another piece of you know, logs or another, you know, device that you will have to profile or connect to in order to diagnose whatever is going on. So, you know, typically it's a 2x work typically, right? Logistics take a long time. So starting a typical project, you know, is in Xcode or in Android Studio, you do a file new project, and you know, you create a Git repository, and you're on your way, right? In hardware, you know, there are things that are totally outside of your control, right? But like, things can get stuck in customs, right? You will get a prototype device, and it gets stuck in customs for whatever, 2 weeks, right? And 2 weeks is a sprint. It's a lot of time, right? And not having a device, you know, it dramatically impacts our productivity. And finally, firmware teams, because, you know, you're going to have a separate firmware team that you will be talking to on a daily basis. They're not often aligned. Typically, firmware teams are either teams that are working closer to the client or closer to manufacturing, but they're not, you know, really aligned with whatever you're doing. So the fact of the matter is, you know, they have their own schedule, and whatever you need is going to be, you know, pushed on the top of or on the bottom of the backlog. And so, you know, there's no guarantee that, you know, whatever you need will be implemented when you need it. So there's, you know, again, something that you really have to account for in your planning. Communication is critical, and it's really hard, guys. It's really hard. So again, I told you about the fact that, you know, the product team is at least in our case, it's typically US. Manufacturing is on the other side of the world, which is Shenzhen. And you have to, you know, you're here in Poland, and you have to talk to both, you know, ideally on a daily basis. And that poses a lot of friction when it comes to, you know, different cultures. You know, Americans are completely different from us, and we are completely different from Chinese, right? And you really have different tools or different, you know, ways of talking to each and every one of these groups. And funny example, you know, talking to, you know, guys from China, they don't reply to your emails. They use WeChat. And one of our project managers, shout out to Maciej, he's great. He actually knows Mandarin. So, you know, he would hop on, you know, in the middle of the night to discuss some stuff. We've had like, you know, like a company dinner once. It's like, you know, like 11 p.m. and Maciej is sitting there with a phone, and you know, he's discussing some project details in Mandarin. So, you know, like I lean against his shoulder and, you know, check out what he's doing, and there are like all these funny, you know, Chinese characters. So one of our partners from the US, he was raising a round for a startup that he's running, and he conducted the whole process over WeChat because he had one of the investors from China, right? So having a Mandarin speaking staff is crucial. I'm well aware that not everybody has the comfort of having, you know, someone on board that speaks Mandarin, but again, communication is really, really hard, and it's crucial for the success of the project. So you really have to watch out, even as a developer, like saying things, or, being that mindset of, I'm not going to communicate this because it's obvious. No, there's nothing obvious across America, Poland, and Shenzhen, nothing. So over communicate, confirm everything, because otherwise you will be ending up in a place where you didn't want to end up in. Distributed work. I'm a huge fan of what COVID induced. So the fact that I can work from home is great for myself, for my family. We get to do workations once in a while, but it does have impact on a project, because all of a sudden, like we've said in the previous slide, you have your product guys in the US, manufacturing is in Shenzhen, and your iOS engineer is in workation in Bangkok, right? And Bangkok being pretty close to Shenzhen time-wise, at least, might be pretty beneficial. But again, there's another set of moving pieces coming at you, and this is something, again, that you really have to account for. Even some bogus stuff, like you're typically working with an early stage startup where these guys have probably like few prototypes, working prototypes of whatever they're building, and you need a device per location, right? Because we're not in the office anymore, right? So we cannot have one shared device for for the QA person to use and for the engineer to use, right? So you really have to have a device per location, which is a stretch for these guys, because oftentimes they don't even have that many devices. Certain projects will not even let you do that. So we've done an automotive project where there's a lot of secrecy going on in automotive, right? So you see those prototype cars that are covered in like the sticky thing, so you can tell that it's like the new model of Mercedes that is driving down the road. So when these guys do projects, they require you to have a separate room in your office that with windows covered, with access control, so that only select few will get a chance to work with whatever they sent you, like a dashboard, like an actual car dashboard. And you cannot have it shipped to Bangkok to one of your mates. Again, distributed work is great, but there are some risks that you will have to mitigate in order to make the project successful. We've touched on this a little bit before, but setting up a project is much lengthier when you have a peripheral device involved. So those devices that you will be getting, they're not even close to what you see in retail stores, right? Like the shiny products, you'll be getting like a crappy PCB board with like strings attached to it. There's like a weird process of starting it or flashing it or whatnot. So there's nothing easy about using that. And these things take time. So setting up a project, a typical project, again, you do a new project, create a Git repository, configure your CI/CD, and you're done. And you can bang out features. The case is really different from an IoT project. So your CI/CD pipeline will be different, because if you want to do automatic tests with a peripheral device, it adds a lot of complexity. There are going to be choices that are made for you, right? So if one of your clients has a project built on top of certain chipset, odds are that vendor of a chipset, they already have their own SDK. So you don't have freedom to use whatever you want, like Bluetooth on iOS. You will have an SDK that you are sort of obliged to use. Again, no red flags, but you should be really ready for this. One sec. My voice is is getting worse and worse. Testing is exponentially more complex. So typically in companies like mine, we have so like you start off by having 0.5 FTE of a QA engineer to 1 FTE of a developer, which means for every developer, you will be engaging a half of a full-time equivalent of a QA person. In IoT, it's different. Again, the process of setting up your test environments takes time. Whenever there's a peripheral involved, you are introducing a whole slew of edge cases of things that you will have to test, like radio interference. They're hard to simulate. They're hard to reproduce, and so that typical sort of 0.5 QA to 1 developer, it's never a good idea on an IoT project. You definitely need much more. And finally, one more word of advice is engage QA folks from the very early days of the project. You may receive some pushback from them, like, hey, there's nothing to test, right? And yes, for a point, there's nothing to test, but there is already things that are being decided upon, and you need to be engaged as a guardian of quality on the project. You need to be engaged in those decisions, and you need to make sure that the impact of these is taken into account when planning your work. So I know there's not a lot of things to test at the beginning of the project, but you can start doing stuff and being productive on day 0 of the project as in QA. This is a controversial one. I'm a huge fan of learning new stuff on a project, right? And typically as engineers, vast majority of our work tends to be like taking data from one place, displaying it, and then storing that data in another place. Whenever there is hardware introduced, the opportunity to learn new stuff is just insane, because even if you have, like, again, your typical get data from somewhere, display that data, and then do whatever, you are working arm in arm with a firmware team, for instance, where like you can get to know the internals of BLE, Linux, embedded, Docker, and a whole lot of other things. It's just like my internal like OCD is desperate for asking questions and learning new stuff. But again, bear in mind that learning stuff also comes at a commitment of time. So whenever you estimate whatever, this feature is going to take that and that much time, you have to be aware that getting from the place you're in right now, when you don't know things that you don't know, to a place where that user story is done, might take much more time, because you'll have to learn something new. And I've been a witness of projects where like there's really a trivial user story that talks about like you have to set up a Docker container or whatnot, and then it turns out it's not like an hour long thing, but it takes days instead of hours, primarily because our engineers our mobile engineers did not have a lot of experience with Docker. Again, this is a great opportunity to learn, but just make sure that, remember from one of the last slides, you will have to over communicate and communicate that this is something new. There's not a lot of shame in saying that you don't know something, but you learn. So just bear in mind that learning comes at a cost of time. Bluetooth, one of the leading technologies in IoT or PXD, is a world of its own. I know that there are people that build their entire careers on top of Bluetooth, right? It's really, really complex. There are so many variations of it. There's just this whole consortium of companies that they work on deciding what goes into the next sort of iteration of the standard. So, you have Bluetooth 5.0, you have BLE, you have, Bluetooth Mesh, you have GAT and how that ties into it. And I feel that the only way to, to get to known Bluetooth is to do a lot of projects with Bluetooth. There are things that books don't cover, that document sets don't cover. And, when you do search for some exotic thing that you discovered on a project on Stack Overflow, there's like, big fat zero of answers or questions for that matter asked. So just bear in mind that, Bluetooth, it sounds simple, right? Because like, you have like one framework on iOS that, deals with Bluetooth and, it's all fun and games and it all sounds relatively simple. Like you read tutorials and it seems, it seems like an easy task, but again, like there are so many different edge cases, implementations, stacks, that differ from device to device. So certain behaviors of Bluetooth on one Android phone might differ from another, Android phone. So again, bear in mind that Bluetooth is, when you have like the project complexity, this is adding another sort of dimension to the complexity that you will have to account for. In hardware, so this is a little hard to explain, but in hardware, the iteration cycles in hardware are slow, right? Hardware is hard, right? It takes a lot of time. But you, on the other hand, when you're doing a companion app or something that interfaces with the peripheral, you will be doing a lot of POCs, right? You will be testing a lot of hypotheses. You will be implementing things just so a very select group of users can test it, and then they come back to you. They say it's a throwaway code, and I know it has a lot of like that kind of message has a lot of impact on morale of the team. You get attached to whatever you build, and that's obvious. But at least the early days of an IoT or PXD project, they tend to be a lot like hackathons. So, and on a hackathon, I do a lot of these, and on a hackathon, you tend to delete more lines of code than you produce, right? So you write something and you delete a lot of that stuff, and you write again, and that's how a lot of the early days of the projects look like. So you'll be testing a lot of things. A lot of things will not work. You'll be killing these little code bases, and you have to get really comfortable with that. It's nothing against you or your coding style. It's just the way these projects are done, and it's more than okay. This is coming from the CTO. It's more than okay to accumulate some tech debt, right? So you don't, given the fact that the likelihood of you trashing certain parts of the project is moderate to high. It's fine to not have things that are perfect. It's fine to accumulate a little bit of tech debt just to get somewhere quicker, but at the same time, you need to be aware of the fact that you are accumulating tech debt that you will eventually have to pay back. Just thinking about working. Multitasking is hard on both iOS and Android. Managing mobile application state is hard, and I don't think that anybody can disagree with me here. I was recently talking to a friend. He's running a startup, and he's like, what's up with these developers? They've been implementing an audio player for 2 weeks. Like, what the hell? And I'm like, dude, is it playing in the background? He's like, yeah, right. So that's how much these things take. I'm not saying, that these developers have done a crappy job. It's just how long these things take. Managing an application life cycle is, it takes much more today than it did, when the iOS first came out, because there's just so much more going on behind the scenes of the OS. It's completely different on iOS and Android. There are some parallels, but again, at the end of the day, these apps behave differently, and they will let you do different things in the background, and they will not let you do different things in the background, from platform to platform. And it's especially hard when you have a peripheral, right? So not only do you have to wake up the app that is, sitting there in the background, and you have a very limited time window to do, whatever you have to do, and encapsulating a connection to a peripheral in that tiny, window of time, again, is really hard. It's harder than managing life cycle of the app. So, and again, it's a challenging thing to test, right? So you really have to have an aware QA person that understands the life cycle of the app, that understands, what things the OS can do to the app, when it's okay for the OS to terminate the app, and whatnot. Like, there's a lot of different edge cases here, and knowing these will only position you guys for success. Telemetry is really important. Telemetry, as in, when you have a peripheral device that you are talking to, that you're interfacing with by, a GAT characteristics. So you send certain values to a characteristic, but you don't really have a lot of outlook into what happens on the device side, right? So that's where telemetry comes into play. That's where, you either have like a, little web server running on the device, or you have a diagnostic port. There are many ways to implement telemetry, but there's one thing that I know for sure, that, if the project that you're working on is sort of, there is a wall between you and the device, so you don't get to peek and take a look at what's going on the device side. It's a red flag, and you will be spending more time debugging and thinking about what's going on over there on the other side, when you don't have a lot of outlook into what's happening on the device. And there can be a lot of things happening. So from crashes to glitches to to all that. So you really have to have a way to know whatever is going on a device. Impact of supply chain. This is, again, no brainer, right? I mean, like, we've been talking about supply chain issues ever since COVID started, right? And now we have a war. And COVID is still there, despite a lot of countries declaring that the pandemic is over. Shenzhen was on the lockdown just last week, and all of these things, they impact supply chain. So despite the fact that you might be perfectly aligned with your manufacturing team or firmware team, you guys are working like an engine, like really closely together. All of this can be screwed up because of the supply chain issues. If you're not one of the big guys, and chances are a lot of these founders are not big guys. They're not Apple. Like, they don't have leverage over supply chain. They don't have their own supply chain, right? They are going to be placed at the end of the waiting line. And just so you know, this is a true story. So we've been working with a company, very innovative company. They scored a lot of accolades or awards on CES and whatnot, and they were just about to ramp up the production of whatever they're doing. I'm not sure I'm allowed to mention what they're doing, but they wanted to ramp up the manufacturing of whatever they were doing, because they just, they were just about to sign a major distribution deal in the US. They go to their one of their partners in China, and that was last year, so 2021. They talked to them. The guys are like, yeah, we can ramp it up, but the ETA for your stuff is 2028. 228, so 6 years from now, which is just, if you think about it, it's insane. Like, we tend to look up, at Apple and how these guys navigate supply chain, but it's easy if you're Apple, if you have, you know, buildings worth of money. If you're a little guy, you know, these things take time, and you really have to account for this. And coming back to the first slide that we've been talking about, that's where a lot of the vaporware comes from, right? Because you know, you really have to wait for all these things. And so you know, founders, you know, they typically, you know, don't like waiting, and so they produce a lot of that, you know, material that sort of tricks you into thinking that the product is ready, but it is really not. Finally, mock devices. Because of, you know, all the things that we talked about today, you know, supply chain issues, different, you know, like things that you have to watch out for when you're communicating over radio with another device. Mocking devices, so creating like a, you know, like a virtual device that sort of behaves or sort of like looks from the app standpoint like an actual device, can help you speed up a lot of your work. And so there are some really interesting libraries like iOS Core Bluetooth Mock from Nordic Semiconductors or BlueZ. The first one does a lot of that simulation through method swizzling. So, you know, it's really easy to roll your app back to whatever it's been before and sort of get rid of that mock device. But mocking devices really can sort of shorten the development time for you. And at the end of the day, you really have to remember that mock device isn't a real device. There's a whole lot of things that can happen between testing your app with a mock device and a real device. But again, it speeds up time for you to, you know, build things, test things. And finally, I'm personally working with Intent on a really interesting project that will turn any Raspberry Pi into any device that you know, you can think of. So it can sort of mimic any sort of device that you will be working with. And therefore, if you're interested to chat about this, or, you know, perhaps get engaged in that project, let me know, because it's a really interesting project. We're almost at 40 minutes, so that's it. My name is Peter Tuszynski, or Piotr Tuszynski, whatever works for you and whatever is more pronounceable for you. You can find some contact details to me down in the slide below. So I have a blog that, you know, that I never update, but feel free to check it out at Dusker, at most of the social networks. And here's my private email address if you want to talk about anything that I've been talking about today. Feel free to drop me a line. Finally, Intent, we are like everybody. We're looking for people who are interested in building IoT. So if anything that I've been talking about today was remotely interesting to you, drop me a line. And I think that we can conclude with that.